हेलो एवरीवन। इस वीडियो में हम CSIR नेट जून 2025 का कॉम्प्लेक्स एनालिसिस के क्वेश्चन डिस्कस करेंगे। सो कॉम्प्लेक्स एनालिसिस में टोटल 3 मार्क्स के 4 क्वेश्चन पूछे गए थे एंड 4.75 मार्क्स के भी 4 ही क्वेश्चन पूछे गए थे। सो इस वीडियो में हम वही 8 क्वेश्चन डिस्कस करेंगे। सो लेट्स गेट स्टार्टेड। दिस इज द फर्स्ट क्वेश्चन जो कॉम्प्लेक्स से पूछा गया था। क्वेश्चन बोल रहा है लेट f फ्रॉम C to C बी अ पॉलिनोमियल मैप फॉर r greater than 0 gamma r from closed interval 0 1 to C with a map where t goes to r e to the power 2 pi it. Suppose there exists a C belongs to R such that integration 0 to 1 mod of this is tends to C as R tends to infinity. Then which of the following option is false? So we need to mark the wrong option. So option 1 is saying that the function z f of 1 by z tends to 0 as mod z tends to infinity. The function f is constant, c is equal to 0 and c is greater than 0. So अगर आप ऑप्शन को ठीक से देखेंगे तो आपको पता चलेगा ऑप्शन 3 और ऑप्शन 4 दोनों में से तो एक गलत होगा ही होगा, क्योंकि ऑप्शन सी में 3 में बोल रहा है c इज इक्वल टू 0 एंड ऑप्शन 4 में बोल रहा है c इज ग्रेटर देन 0। दोनों एक साथ नहीं हो सकता। So 3 and 4 में एक गलत होगा। So any one of 3 and 4 is our required option. So from that I can say that option 2 is definitely correct. ऑप्शन 2 में क्या बोल रहा है, f कांस्टेंट है। So let us consider f of z has to be a constant number a. I do not know anything about it. It can be positive, it can be negative, it can be or any complex number, it can be a 0. I do not know anything about it, but a constant. Now gamma rt is given by r e to the power 2 pi it, ठीक है ना। So then they are saying gamma dash लगेगा, let's calculate gamma r dash t which is equal to r 2 pi I e to the power 2 pi it, ठीक है ना। So I calculated gamma dash rt. Now let's calculate this integral which is equal to integration 0 to 1 mod of, I can change this composition as f of gamma r t gamma r dash t whole of dt, which is equal to integration 0 to 1, this is equal to a and this is equal to r 2 pi I e to the power 2 pi I t whole of dt. Now mod of 2 pi I t is 1, mod of I is 1, so which is equal to integration 0 to 1 r, as r is strictly greater than 0, they said that a 2 pi of dt. So इसे अगर हम इंटीग्रेट करेंगे तो हमें मिलेगा 2 pi mod a r. Now there are few cases. Now case 1 I can say that mod a is greater than 0, and in case 2 I can say that mod a is equal to 0. Now if mod a is greater than 0, then this integral tends to infinity as r tends to infinity, ठीक है ना। And if mod a is equal to 0, then this integral, this vanishes, this becomes identical to 0, that tends to 0 as r tends to infinity, ठीक है ना। Now note that they are saying this tends to c where c is a real number, so mod a cannot be greater than 0, so mod a has to be equal to 0. So mod a agar 0 hoga, that tends to 0 which is equal to c, right? So the value of c is 0. So option 3 is correct and option 4 is wrong, but we need to mark the wrong option, so option 4 is our record option. Let's head on to our next question. Now this question is saying that x be the image of interval closed interval 0 1 under the Möbius transformation f of z equals to z minus 1 by z minus I by z plus I, then which of the following statement is true, ठीक है ना। Now as x is image, x equal to image of 0 1 under the Möbius transformation f, or other word I can say that f of 0 1, ठीक है ना। Now if we choose z belongs to closed interval 0 1, so z equals to x plus 0 आई, क्योंकि इमेजिनरी पार्ट तो होगा नहीं, क्योंकि 0 1 क्लोज इंटरवल में. सो in that case the value of f of z, which is equal to value of x, which is equal to x minus I by x plus I. So if I calculate f of mod of f of z, that gives you mod of x minus I by mod of x plus I, which is equal to 1. So I can say that fz lies on an unit circle, क्योंकि इसका मॉड्यूलस वैल्यू 1 होगा. Now f of 0 is 0 minus I by 0 plus I, which is equal to minus I by I, which is equal to minus 1. So इसे हम लिख सकते हैं e to the power I pi. So cos pi plus I sin pi. Okay. Again f of 1, that is 1 minus I by 1 plus I. So that is 1 minus I whole square by 1 square plus I minus I square. So that is equal to minus 2I by 2, which is equal to minus I, equal to e to the power minus I pi by 2. That gives e to the power minus, so that gives it cos 3 pi by 2 plus I sin 3 pi by 2. ठीक है. So इससे हम क्या बोल सकते हैं, सी एनी वन ऑफ दिस टू ट्रू. एक और चार्ट तो फॉल्स होगा, क्योंकि दे आर द लाइन सेगमेंट जॉइनिंग -1 1 and -1i, क्योंकि this points line on a unit circle, so any one of 3 2 and 4 is true. Now if we choose a point 1 by root 3 that is lying on the unit 0 1, so let's see what happened about what is the image of 1 by root 3. So that gives you 1 by root 3 minus I by 1 by root 3 plus I. ठीक है ना. Now 1 by root 3 minus I 1 by root 3 plus I, that is equal to 1 minus root 3I by 1 plus root 3I. So if I break it, that's becoming 1 minus root 3I whole square over 1 plus 3. So that is equal to 1 minus 3 by 1 plus 3 plus I minus 2 root 3 by 1 plus 3. Now see, its real part is negative as well as imaginary part is negative. Now, so this point has to lie on the third quadrant. So now observe that this point, this is the only case where this unit circle is passing through the third quadrant. In this case, it is not passing through the third quadrant. So option 2 is the correct option. Now this question is saying that which of the following statements is true. So statement 1 is there exists an entire function f such that fn 0 is equal to n factorial by n to the power n for all positive integers n. There exists an entire function f such that fn 0 is equal to n factorial is whole to the power n to the power n for all positive integer n. There exists an entire function f such that fn 0 is equal to this, and there is an entire function f such that this. So इसमें हमें correct option mark करना होगा. Now they are saying f is an entire function. So let's consider the series expansion, but Taylor series expansion of f about the point 0 as summation a n z to the power n. This is Taylor series expansion of f about the point 0, where we know that a n is equal to f to the power n 0 by factorial n. ठीक है ना. Now note that here in each option they are saying f is an entire function. ठीक है ना. So अगर f entire function होगा, so इसका पावर सीरीज एक्सपांशन में रेडियस ऑफ कन्वर्जेंस क्या होगा. रेडियस ऑफ कन्वर्जेंस को मैं अगर इफ आई कंसीडर दैट एज टू बी आर, सो रेडियस ऑफ कन्वर्जेंस तो इन्फिनिटी होगा. ठीक है ना. सो रेडियस ऑफ कन्वर्जेंस अगर इन्फिनिटी होगा, सो हम बोल सकते हैं रेडियस ऑफ कन्वर्जेंस क्या होता है. आर इज इक्वल टू 1 बाई लिम्स ऑफ और अपर लिमिट n टू द पावर mod of n टू द पावर 1 बाई n. ठीक है ना. लिम्स ऑफ n टू द पावर 1 बाई n ऐसा होता है. ठीक है. सो हम क्या बोल सकते हैं, हमें ऐसा n चूज करना होगा जिसके लिए लिम सुप an टू द पावर 1 बाई n 0 होगा। अगर n टू द पावर 1 बाई n 0 होगा तभी तो r का वैल्यू इन्फिनिटी होगा। So let's see which of the following, which of the given n is satisfying n to the power 1 by n is equal to 0. ठीक है ना? Now for the first case n क्या होगा? n होगा fn 0 for the first option, fn 0 by n factorial. So here पर fn 0 का वैल्यू क्या होगा? n factorial by n to the power n into n factorial. So that is cancelling n factorial. I'm getting 1 by n to the power n. So therefore mod of an is whole to the power 1 by n, that gives you 1 by n, which tends to 0 as n tends to infinity. So therefore for that purpose lim so an to the power 1 by n that is equal to 0. So ऑप्शन ए के लिए 0 हो रहा है, so ऑप्शन ए करेक्ट ऑप्शन होगा क्योंकि दिस इज अ 3 मार्क्स क्वेश्चन, सो इसमें एक ही ऑप्शन करेक्ट होगा, सो ऑल द रिमेनिंग ऑप्शंस इज रॉन्ग। तो आप चेक कर सकते हो, इन ईच केस यू वुड गेट लिम सुप इज नॉट इक्वल टू 0। दिस इज अगेन अ वेरी इजी क्वेश्चन जो पूछा गया था कि लेट एफ बी एन एंटायर फंक्शन सच दैट एफ ऑफ सी इज इक्वल टू सबसेट ऑफ दिस, देन व्हिच ऑफ द फॉलोइंग स्टेटमेंट इज ट्रू। तो हमें करेक्ट स्टेटमेंट मार्क करना होगा। नाउ एज एफ इज एन एंटायर फंक्शन वी डू नो दैट if f is a non-constant entire function, then image set of f is dense in C. Now if you draw this y is equal to x plus 1, y is equal to x plus 1 is a line like this in the complex plane. Okay, so now this line is closed, so I can say that image set of f is not dense in C. So image set of f is not dense in C, it means f is a constant function. F cannot be a non-constant entire function, so f of z is equal to some c, ठीक है ना? सो अगर f of z c होगा सो ऑप्शन 2 करेक्ट होगा क्योंकि f of z by z tends to 0 as z mod z tends to infinity. So correct option is our option 2. It was a very easy question. Now moving on to the next question.
Is entire, f double dash is entire, and so on. Each of them is entire. Now we know that zeros of non-constant entire function are isolated. So these all sets are cannot have a limit point. Now, so from that purpose, as they don't have any limit point, I can say that they are at most countable. At most countable. So each of them are at most countable. So this is at most countable, this is at most countable. So I can say that a complement is at most countable. Now as a complement is at most countable, so from that I can say that a has to be non-empty. A is not finite as a is infinite and uncountable set. Option 3 and option 4, all of them are correct. So that's all of this question.
This is the next question, and the question is saying that let f be an entire function, then which of the following statements are true? Statement 1 is saying that f of z equal to f of z plus 1 for all z belongs to C, then f is constant function. F of z equals to f of z plus 1 equal to f of z plus I for all z belongs to C, then f is constant. If f of 1 by z has a removable singularity at 0, then g is constant function, and if is a non-constant function, then f of 1 by z has a pole at 0. Now the given that f is an entire function, so first let's check our option 1. Option 1 is saying that f of z equals to f of z plus 1. So what I am doing, I'm considering the function f of z equals to e to the power 2 pi I z. So now the function e to the power 2 pi I z, अगर मैं calculate करूँ f of z plus 1, f of z plus 1, this is equal to e to the power 2 pi I of z plus 1. So that gives you e to the power 2 pi I z to the power 2 pi I. Now e to the power 2 pi I is 1, that gives you e to the power 2 pi I z, which is equal to f of z. So now this function f is non-constant. So of statement 1 or option 1 is false. So now let's move on to option 2. ऑप्शन 2 क्या बोल रहा है? ऑप्शन 2 बोल रहा है f of z equal to f of z plus 1 equal to f of z plus I for all z belongs to C, then f is constant function. Now a very well-known theorem in complex analysis saying that any double periodic function has a singularity. Again I am saying any double periodic function has a singularity if it is non-constant. मतलब अगर डबल पीरियडिक में कुछ फंक्शन लूँ, इसमें अगर वो इंटायर नहीं होगा तो उसमें एक सिंगुलरिटी होगा ही होगा, क्योंकि दिस इज अ डबल पीरियडिक फंक्शन z प्लस 1 एंड z प्लस आई एंड f इज एन इंटायर फंक्शन, तो इसमें कुछ सिंगुलरिटी होगा नहीं, तो इससे हम बोल सकते हैं f इज डेफिनेटली अ कांस्टेंट फंक्शन. सो ऑप्शन 2 is true. Now let's talk about option 3. So option C3 क्या बोल रहा है? If fz has a removable singularity at 0, then f is constant function. तो f of z, let g of z, what I am considering g of z equals to f of 1 by z. ठीक है ना? So हम क्या बोल सकते हैं इसमें? g has a removable singularity at z equal to 0. Has a removable singularity at z equal to 0. So then by Riemann removable singularity theorem, there exists a m greater than 0 and a delta greater than 0 such that मैं क्या बोल सकता हूँ? Mod of g of z is strictly or less or equals to m for all z satisfying 0 less than mod of z minus 0 less than delta. ठीक है ना? That I can say by Riemann removable singularity theorem. Now अगर g of z इक्वल टू f of 1 by z होगा तो मैं कंसिडर कर रहा हूँ w इक्वल टू 1 by z. ठीक है ना? देन f of w इक्वल टू f of 1 by z which is equal to g of z which is equal to g of 1 by w. ठीक है ना? Now note that in this interval what I can say, mod of z less than delta, that would imply 1 by mod z greater than delta. So 1 by mod z is mod w greater than delta. Therefore, and on this interval f of g of 1 by z equal to f of w. So therefore f of w is less or equals to m for all mod w greater than delta. So now if we consider the circle about the point 0 with the radius delta, what I can say, इस सर्कल के बाहर में f जो फंक्शन है that is bounded. Now let's consider all such w such that mod of w is less or equals to delta. This is a compact interval, compact set in complex plane. So इसमें तो f constant होगा ही, इसमें तो f bounded होगा ही. So f is bounded on this set as well as on this set, जिसका union पूरा C होगा. So इससे हम क्या बोल सकते हैं? f is bounded on the entire complex plane. So अगर f is bounded on the entire complex plane, f is a bounded constant entire function, by Liouville's theorem I can say f is constant. So option 3 is definitely a correct option. Now moving on to option D, if they are saying that if f is non-constant function which is also entire, then f of 1 by z has a pole at 0. Now if you consider the function f of z, same function e to the power 2 pi I z, then f of 1 by z का जो लॉरेंस सीरीज एक्सपेंशन होगा इसमें 1 by z का इन्फाइनाइटली मेनी टर्म होगा. सो 1 by z का अगर इन्फाइनाइटली मेनी टर्म होगा तो इससे हम बोल सकते हैं f of this function has an essential singularity at z equal to 0. ठीक है ना? सो अगर फंक्शन का एसेंशियल सिंगुलरिटी होगा तो इससे हम बोल सकते हैं कि दिस फंक्शन डू नॉट हैव एनी पोल at 0. So option 4 is wrong. So therefore the correct option are option 2 and option 3. Now we are heading on to our next question. The next question is saying that gamma such that closed interval 0 1 to c be the function where t goes to e to the power 2 pi I t I equal to integration gamma e to the power z e to the power 1 by z. This is the function gamma. This is the I, and then which of the following statement is true? I का value क्या होगा? So what I am doing, I am considering f of z is equal to e to the power z e to the power 1 by z. इस फंक्शन को मैं सेट कंसिडर कर रहा हूँ, ठीक है ना? Now observe that inside this contour f z has only one singularity at z equal to 0. ठीक है, तो दिस फंक्शन तो एंटायर फंक्शन है, दिस फंक्शन इज एंटायर, दिस फंक्शन की इस फंक्शन की e to the power 1 by z फंक्शन की 0 पॉइंट में सिंगुलरिटी होगा. सो दिस फंक्शन हैज ओनली सिंगुलरिटी एट 0. सो देयरफॉर i का वैल्यू क्या होगा? i का वैल्यू होगा 2 pi I रेसिड्यू ऑफ f एट 0. दिस इज बाय रेसिड्यू थ्योरम. सो अगर मैं रेसिड्यू f का रेसिड्यू एट द पॉइंट 0 निकाल पाऊँ तो आई एम डन. नाउ व्हाट इज रेसिड्यू ऑफ f एट द पॉइंट 0? Residue of f at the point 0 is the coefficient of 1 by z in the series expansion of f about the point 0, right? I'm saying it again. Residue of f at the point 0 is the coefficient of 1 by z in the series expansion of f about the point 0. So मुझे coefficient of 1 by z निकालना है. Series expansion of f का निकालना है. Now series expansion of f is the series expansion of e to the power z multiplied by the series expansion of e to the power 1 by z. Now the series expansion of e to the power z is summation. We know that the series expansion of e to the power z is summation j equal to 0 to infinity z to the power j by factorial j. So in the same way, e to the power 1 by z, that would be summation k equal to 1 to infinity, क्योंकि इसमें तो 0 होगा नहीं. Or rather I can even consider k equal to 0 to infinity z to the power minus k, क्योंकि z नीचे होगा, z to the power minus k is whole to the k to the k factorial. ठीक है ना? सो इस सीरीज में आई नीड टू कैलकुलेट द कोएफिशिएंट ऑफ 1 by z. सो अगर मैं इसको थोड़ा एक्सप्रेस करूँ, आई कैन राइट दिस इज इक्वल टू for z equal to 0, that becomes 1 by 1 factorial plus z by again factorial 1 plus z square by factorial 2 plus z cube by factorial 3 and so on. This multiplied by this. For the 0, this is 1 factorial or 1 plus 1 by z plus 1 by z square into factorial 2 plus 1 by z cube into factorial 3 and so on. Now 1 by z कैसे कैसे आएगा? 1 by z आएगा अगर मैं वो फर्स्ट टर्म है उसके साथ मैं सेकेंड टर्म को मल्टीप्लाई करूँ. अगेन इफ आई मल्टीप्लाई this term with z square, multiply this term with z cube, ऐसे ही 1 by z आएगा. So if I write 1 by z, तो फर्स्ट आएगा 1 by factorial 1. फिर if I multiply this term with this term, I would get 1 by factorial 2. Then if I multiply this term with this term, I would get 1 by factorial 2 into factorial 3 plus 1 by factorial 3 into factorial 4 plus so on. ठीक है ना? ऐसे ही आएगा. So this is the residue of f about the point at the point 0. So I का वैल्यू क्या होगा? 2 pi I summation 1 by 1 factorial, it's not summation, 1 factorial plus 1 by 2 factorial plus 1 by 2 factorial into 3 factorial plus 1 by 3 factorial into 4 factorial and so on. So that is equal to 2 pi I summation n equal to 0 to infinity 1 by n factorial n plus 1 factorial. which is our option 4. So option 4 is our correct option. This is the last question जो complex से पूछा गया था, and question is saying that due to the word x be the punctured unit disk and f be a bijective holomorphic map of due to the power x onto itself, then which of the following statement is true? Statement 1 is saying that limit z tends to 0 fz does not exist. Limit z tends to 0 fz exists and has absolute value less or equals to 1. Limit z tends to 0 fz का value 0 होगा and there exists at theta belongs to what, such that f of z equals to e to the power I theta z, although z belongs to d to the power x. ठीक है ना? Now note that on this punctured unit disk f is holomorphic, so z equals to 0 is the only singularity. So in other word I can say that z equals to 0 is an isolated singularity of f. Now so 0 is the isolated singularity of f. Now we know that singularity is 0 singularity है, इसलिए there are 3 possible cases. One is essential, second one is pole, and third one is removable singularity. ठीक है? Now अगर 0 f का essential singularity होता तो एक चीज आपको ऑब्जर्व करना होगा. इफ आई टेक एनी पॉइंट d z which is very near to 0, मतलब z very near to 0 dash tends to 0, f of z अगर 0 का बहुत पास होगा तो z will lie inside this punctured unit disk somewhere very near to 0, मतलब ऐसे जगह पे होगा z. लेकिन अगर z अगर d to the power, तो z d to the power x का मेंबर होगा. अगर z d to the power x का मेंबर होगा, so image of z that is fz is also belongs to d to the power x, so fz तो बाउंडेड होगा. नाउ f का अगर z equals to 0 एसेंशियल सिंगुलरिटी होता है तो fz तो बाउंडेड हो नहीं सकता बाय कैसोरेटिव-वाइस्टर्स थ्योरम, so z equals to 0 cannot be an essential singularity. Now so the possible cases are pole and removable singularity. Now if z equals to 0 is a pole, then I can say that limit z tends to 0 mod of fz is infinity. बट इन द सेम आर्गुमेंट, क्योंकि 0 के जितने पास भी z जाएगा fz का वैल्यू तो d to the power x में रहेगा, तो बाउंडेड ही होगा. सो दिस इज ऑल्सो नॉट द केस, सो पोल भी नहीं होगा. सो z equals to 0 is a removable singularity. सो z equals to 0 removable singularity का मतलब क्या होता है? लिमिट z tends to 0 f of z exist. सो पहला वाला जो ऑप्शन था वो गलत था. नाउ नोट दैट on this unit disk 0 less or equals to f of z, 0 strictly less than f of z, strictly less than 1. so अगर मैं लिमिट ले लूंगा, लिमिट z tends to 0, f of z का वैल्यू तो लेस और इक्वल्स टू 1 आएगा. सो ऑप्शन ट्रू 2 इज ट्रू. सो ना f का अगर रिमूवेबल सिंगुलरिटी होता है at the point 0, so I can say that f can be extended holomorphically to a function f के upon d to the power x. मतलब f is holomorphic on d to the power x and has a removable singularity at 0. So f on the entire सर्कल f को हम एक होलोमॉर्फिक फंक्शन में एक्सटेंड कर सकते हैं, क्योंकि कोई भी पॉइंट में अगर रिमूवेबल सिंगुलरिटी होता है तो उसे हम होलोमॉर्फिक फंक्शन में एक्सटेंड कर सकते हैं. नाउ हियर इज इंटरेस्टिंग थिंग. अगर बाइजेक्टिव holomorphic function, holomorphic map from d to the power x to itself extends holomorphically to 0 and the only possible extension consists with bijectivity is rotation. रोटेशन का मतलब क्या है? there exists, रोटेशन का मतलब है that is there exists theta belongs to r such that f of z equals to e to the power I theta into z, where for some theta belongs to r. This is a very key result, and ऐसे क्वेश्चन हर साल पूछा जाता है, हर साल हम इसी स्टेप इसी रिजल्ट को यूज करते हैं. So you need to remember this result. So now f of z equals to e to the power I theta into z. So option 4 तो correct होगा. And अगर f of z equals to this, then limit z tends to 0, f of z का वैल्यू भी 0 ही होगा. So this is also correct. So 2, 3 and 4 are the correct option.